All right, let's dive into Apache Airflow. You've probably heard of it. It's this incredibly powerful open source tool that's basically the secret sauce running behind the scenes at thousands of companies, from scrappy startups all the way to Airbnb, where it was first created. It's the tool that brings a beautiful code driven order to data chaos, and we're about to break down exactly how it does it.
So, here's the game plan. First, we're going to talk about the problem. Why do we even need a tool like this? Then, we'll get into what Airflow actually is and how its different parts work together. After that, we'll look at a simple workflow with a little bit of code to make it real, and finally, we'll zoom out to see where it fits in the real world, including its biggest strengths and, yup, its weaknesses too.
Okay, so to really get why a tool like Airflow even exists, you first have to understand the problem it's trying to solve. And in the world of data, that problem is often a huge, messy challenge of what you could call coordinated chaos.
Think about it. Modern companies are just swimming in data, right? But it's not this neat, tidy river. It's more like a whole chain of really specific, delicate steps. You have to fetch data from one place, clean it up, use it to train a machine learning model, and then update a dashboard. But what happens if the cleaning step fails? Or even worse, what if they all run completely out of order? Total chaos, that's what. Let's stick with a cooking analogy. Imagine you're in a kitchen trying to make some complex, fancy dish. But there's no head chef. No one's in charge. So the vegetables get chopped after the main course is already on the plate. The oven gets preheated hours after you needed it. That completely dysfunctional kitchen, that's exactly what a data pipeline looks like without a proper manager. And that chaotic kitchen, that's exactly where Airflow comes into the picture. It's designed to be that head chef, that kitchen manager who brings sanity, process, and a clear order of operations to the data kitchen. So, what Airflow does is it gives you this central command center, a place to define, schedule, and keep an eye on all these complex data recipes, or as we call them, workflows. It makes sure, with absolute certainty, that every step runs at the right time, in the right order, and it even automatically handles stuff like failures, retries, and logging for you. Now, this right here is the absolute core philosophy of Airflow, and honestly, it's a total game changer. Configuration as code. Instead of clicking and dragging boxes around in some UI, you define your entire workflow, your entire data recipe, in a Python script. This is huge because it means your data pipeline is now just code. You can version control it, test it, and collaborate on it, applying all the best practices from software engineering directly to your data operations. Okay, so how does this whole thing actually tick? Let's break down the three fundamental building blocks of any workflow in Airflow. And don't worry, I promise it's way more straightforward than it might sound. First, you have the DAG. That stands for Directed Acyclic Graph, which is a super nerdy way of saying it's the master recipe, the entire blueprint for your workflow. It's directed because data flows in one direction from start to finish, and it's acyclic because it can't have loops. It always moves forward towards a final goal. Simple as that. Okay, so if the DAG is the whole recipe, a task is just one single step. It's one specific self-contained action, like download today's sales data, or process user images, or generate a report. Each task is one little node in your overall graph. And then, how does a task know what to do? Well, that's the job of an operator. Think of the operator as the template, the verb that brings a task to life. Airflow comes with a ton of them already built. You want to run a simple command line script? Use the bash operator. You want to run a piece of Python code? There's a Python operator for that. The operator is the actual engine that does the work. All right, theory's great, but let's make this real. Let's see what this looks like in practice, because this is where you really see the beauty of treating your workflows just like any other piece of code. I mean, look at how clean this is. In Python, you just define your tasks, and then you set their relationship with these simple little arrows. Task 1, dagger tag task 2. That's it. That's the code. It's an incredibly readable and elegant way to tell Airflow, hey, you absolutely have to run task 1 first, and do not start task 2 unless task 1 finishes successfully. And once you've laid out your plan in code, you can just step back. Airflow becomes your tireless assistant, handling all the grunt work. It manages the schedule, whether that's hourly, daily, or something more complex. It enforces those dependencies we just talked about. If a task fails, it'll automatically try again. And you get all your logs in one place, plus this amazing web UI to see exactly what's going on in real time. It's the whole package. Okay, so we get the how, but what about the where? where does airflow actually get used in the real world? And just as important, where is it maybe not the right tool for the job? Let's take a look. You'll see airflow pretty much anywhere you have data that needs to be processed in batches. I'm talking classic ETL pipelines: extract, transform, load. That's its bread and butter. It's also a beast for orchestrating complicated machine learning pipelines, from getting the data ready to training the model to pushing it live. And tons of companies use it to schedule the daily jobs that refresh their dashboards, or to run regular checks to make sure their data is clean and reliable. But look, no tool is perfect, right? And it's important to have a balanced view of airflow. On the one hand, its biggest pro is its maturity. It's been around, it's battle-tested, it has a massive community, and you can find engineers who know it. The flip side of that coin, though, is that its age can sometimes show. It was really built for predictable, time-scheduled jobs, and it can feel a little clunky when you're trying to deal with more modern, dynamic, event-driven workflows. So let's be super clear about this. If your world is all about real-time streaming data, data flying in from sensors or live clicks on a website, Airflow is not your guy. It's also not built for tasks that need to run every couple of seconds. Its sweet spot, where it truly shines, is for those complex, batch-style workflows that run maybe every hour or every day and demand rock-solid reliability.
So when you boil it all down, what's the big takeaway? Airflow's real magic, its superpower, is its ability to take a tangled mess of scripts and cron jobs and transform it into a system that is reliable, observable, and repeatable. It brings the structure and discipline of code to the wild west of data pipelines.
And this all leads to a really interesting question, one that's shaping the future of data engineering. As the world moves towards faster, more dynamic, event-driven data, will the established giants like Airflow be able to adapt, or are we going to see a whole new generation of tools built from scratch for this new reality that completely redefine how we think about workflow automation? That's definitely the space to watch.